Oh, great, Tim. So last week we have started to make a revision for the generalities about functions. And this week also we have continued our lesson. So last week we talked about the intervals in R and how do I find the domain of definition of a function. We also explained what's the meaning of parity or the symmetry. Okay, so the function if it's even or odd. And this week, we explained how can we prove a center of symmetry and how can we prove an axis of symmetry. First of all, in order to prove that a function has an axis of symmetry or it's an odd function and it has an axis of symmetry, you have to prove. So in order to prove that a function has an axis of symmetry, you have to prove that f of 2a minus x is equal to f of x. Okay, so a is the axis of symmetry. And in order to prove that we have a center of symmetry, we have to prove that f of 2a minus x plus f of x equals 2b. Let us do an application. Here we have a function. Just a second. Okay. Here we have a function f of x equals x squared minus 4x plus 3, and we are asked to prove that x equals 2 is an axis of symmetry. So we follow the rule f of 2a minus x. So 2 times 2 is 4. 4 minus x. What's the meaning of f of 4 minus x? Means every time you see x, you have to replace it by 4 minus x. So the function was x squared minus 4x plus 3. So we replace x by 4 minus x. And when you expand it, you will get x squared minus 4x plus 3, which is the main function. So that's how we prove that x equal to 2 is an axis of symmetry. And now, to prove a center of symmetry, we have this function, which is h of x equals x minus 4 into x minus 2. We need to prove that I, which is 2, 1, is a center of symmetry. So we need to prove that f of 2a minus x plus f of x equals to 2b. So we calculate h of 2a minus x. We get minus x over 2 minus x plus h of x. So in order to make this, we need to do the same denominator. So we multiply it by minus, and then we do same denominator, you will get 2. 2 is 2 times 1, 2 times b. So prove that I is a center of symmetry. Also, we explained about having two curves. Okay, if you look at this curve, we need to study the relative position of these two curves. Between 1 and 5, C is above C prime. Between 5 and 8, C prime is above C. But at 5 exactly, C and C prime, they intersect. So that's the studying the relative position of two curves. That was everything we have explained in this lesson. We solved already number 1. We solved number 5, which is telling if it's an even or odd. I already explained this. We also solved exercise 8 and 9, both of them, one how to prove an axis of symmetry and the another one how to prove center of symmetry. And I started with our new lesson, which is limits. Okay, limits and continuity. In this lesson, we're going to talk about the limits of a function at infinity, the limit of a function at a point. Also, how can I tell that the function is continuous or not? I only explain the limits of a function at infinity. So let us do or talk about the limit. What's the meaning of the limit? The limit of a function, it's actually telling the fate of the function on its domain. If you look at this curve, x is increasing. So x is increasing till plus infinity. What's happening to the function as x is increasing? If you can see, as x increasing, the function itself, it's going upward to plus infinity. So we say that the limit of the function, the fate of the function as x is going to plus infinity is plus infinity. Okay, so we write lim x tends to plus infinity. What's the meaning of x tends? X is approaching plus infinity. The function itself, it's going to plus infinity as well. Look at this second function. This function, as you can see, as x also is tending to go or approaching to plus infinity, the function is going downward to minus infinity. So we say that limit of the function when x is approaching plus infinity is minus infinity. Okay? Of course, this is graphically. Let us continue. Look at this function. This function as x is approaching where? Minus infinity. So x is approaching minus infinity. The function is going to plus infinity. Its limit is to plus infinity. And the last one, as x is approaching minus infinity, the function itself is going downward, which is minus infinity. So when I say the limit, as graphically, I'm just looking where is the fate of the function as x is approaching plus infinity or minus infinity. This is graphically. While if we want to calculate this, we just replace, when I say x tends to minus infinity, means if I have a function x, I replace x by minus infinity. So minus infinity. Minus infinity squared, it's plus infinity. But minus infinity cubed, it's minus infinity. Minus infinity to the power 4 is plus infinity. Radical plus infinity, it's plus infinity. Also here, limit when x tends to plus infinity for x is plus infinity. Plus infinity squared is plus infinity. Plus infinity cubed is plus infinity. And plus infinity to the power 4 is plus infinity. I will stop here, okay? Because that was that's the only thing we have explained till now. And later on, we will talk when we do the limit when x tends to plus infinity, but we don't get an infinity. Okay, so we were going to talk about this and what happened in this case. So that was our lesson. We have started already with limits. And next week, we are going to continue our lesson.